Who was asking? Yes. So the day that I give you the quiz answer key, we'll do a formula sheet just like for the last test. Yeah.
So would it be like the probability of B times C given B?
So one option is it could be, so the probability C and B could be the probability of what, I'm sorry, B, you said, right?
Yeah.
What's the other way I could write that? Probability of C times the probability of B given C. And then you say, okay, and the reason why it's important to realize you can write it two different ways is because I know, what do I know? I know B, and I know probability of B given C, and I know probability C. So I can put C and B given C. I can do that one and figure out the and. That was interesting. Right? So you write symbols for what they tell you. You write symbols for what they ask you, and you see how they relate. You put the right stuff in the right place. That's really all it is. All right. Okay. Let me see. Any other freaky homework problems? I don't think there's too much freakiness. There's another problem that's like the one we just did, number 44 through. Yes.
The other one. Yeah.
What is that?
Can you do that one?
Which one? Okay.
No.
Up here?
Yeah.
18.
Mm-hmm.
Oh, all right. I think in the section, if you don't know cards too well, or do you know cards? You don't know cards? A little bit. Okay. I can't remember. I don't think it's this book. I think it's the other book. They assume a lot with this book, I think. I don't think they give you the breakout of cards in here, do they?
You can look it up online.
Yeah, you can look it up online. That's the next thing I was going to say. You can let every damn thing up online. But, so you got a deck of 52 cards. They're red and black cards. What percentage of the deck is red? Half, 50%. So that's the probability of getting a red card would be 50%. There's a gimme. It could be 26 out of 52 cards. Half of the deck is red. So if you don't know cards too well and they ask you about cards, you can just Google deck of cards and they should splay it out for you. Yeah? Okay. What was I saying? That one was like that. This one is all about symbols. I like it. And I love the people that just copy from the back of the book that sometimes you don't do a good job of noticing little things. So, which makes it way too easy to catch you. I'll just stop right there. Yeah, I was going to say catch your stupid ass, but this I don't. The way that they represent opposite probabilities. So the opposite of A would be, let me just say it again. Opposite of A is they use this. They use a little prime. That thing is called a prime. I probably will, without even thinking about it, use this, because that's what I'm used to. That symbol on top of a probability statement is like the opposite of that thing. The book uses this little symbol. So when people are copying out of the back of the book, they don't notice this is there, and what they write makes no sense, because they don't put that. For example, I'm not saying you're going to cheat, but some of you are already, and you're not doing yourself any favors. Okay, I think that's it. I want to show you how the homework. Oh, here, real quick. Remember earlier? They said E and F are mutually exclusive, so what can you immediately write down? Probability of E and F is 0. You can write that down, and then when they ask you a question, you can use it in the formula for what they ask you. It's crazy. Will they tell you that they're independent? J and K are independent, which means probability of J given K equals probability of J. Then that problem becomes stupid easy. Right? Hopefully. Okay. All right. I think that's enough from there. Yes. Okay. Cool. I like it. I like it. I like it a lot. All right. So we're going to do a little bit going to get a little bit into chapter 4, and then what I want to do is get a little bit into chapter 4, so then I feel a little bit better about spending more time next class on any specific questions and reviewing for the quiz. You guys with me? So you've got to get into the homework and actually bring questions, right? Don't just copy the answer down and feel like that did anything for you. It did nothing for you. Okay. Cooperate. There you go. So, what we do immediately after chapter 3 is we get into another way to give data. So, what have we seen already? What's one way for somebody to give me data? Well, the only way we've seen is just somebody to give me a big ass list of data, right? That's all we've done. Well, what's another way to give me data is if there's a lot of repeats, I really don't feel like writing them down over and over and over again. So let me do a little example. What I'm going to try to do today. Oh my gosh, let me preface this with something here. I'm going to try to show you where the formula comes from and how it really is the same formula we used before. It's just altered to match the way they give me data. We're going to do this over and over. What are the two most important things to calculate from a set of data? What are the two biggies, the two most important things to know? The center, the mean. We're going to say the mean wins, right? And, of course, the standard deviation. I love it. I want somebody to go, the hymns. No, standard deviation. Is everybody with me? If I have a new set of data and they give it to me in some funky way, I still want to know how can I get the middle, the center, the mean, and the spread, the standard deviation. How can I get those two things? Is there an easier way to do it than just write out the whole list and then do it? So we're going to do a little tiny list, but then I'm going to show you why I'd rather have a different way to do it because it could be a gigantic frickin' list otherwise. So let's deal with, let's just do a list of 10 things here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good job, Jeff. All right, now if I asked you, now this is going to take some coming along with me, as it always does. We're going to calculate the average like we normally do, but then I'm going to do some weird shit towards the end to convert it to the way we're going to do. See how many repeats there are? What percentage of the data up there is ones? 40%. I like it. And so forth, right? So another way I could represent, let me try to teach us, let me try a little bit different way to do this than I normally do. Can't I, instead of having that stupid list over there, can't I instead list, what are all the possible values of x? 1, 2, 3, and 4. What's probably I would get a 1, what you just said, 40%. There's probably get a 2, 30%, 3 out of 10, right? 30%, just in case people are like, where the shit are they getting that from? Probably get a 3, 10%, 1 out of 10 is 3, and 4. 2 out of 10. And how do I know this is a valid table here? All the probabilities add up to 1. And then there's another little stupid thing, but they're all between 0 and 1, right? Of course they are, but that's another thing to check. So they do add up to 1, check. And they're all between 0 and 1. Check. Right, because I could have 1.5 and negative 0.5, and they add up to be 1, but what the hell is 150% chance of happening? Oh, God, no. 150% chance of rain is like giant raindrops. No. All right, now watch. I'm going to calculate the average like I normally would in Chapter 2, and then I'm going to show you how it relates to the way we're going to do it now when they give me data like this. Okay? Because I want to say something. If they just gave me this, is there necessarily 10 data points? No. There could be 18 billion data points, and 40% of them are 1s, 30% are 2, blah, blah, blah. Do you guys understand? So that list could get stupid huge. I want a quicker way to do it. This is a nice small list, so we can do it both ways. So if I wanted to calculate the average, how do I do that? Add them all up. Divide by half my R. Okay, so then I get 4 1s plus 3 2s plus 1 3 plus 2 4s divided by 10. Now on the side here, I'm going to go ahead and do it, but then I'm going to keep going a different way. So the old way, in fact, we wouldn't probably even have done that, but you guys can see it's a quicker way to write the shit, right? 4 1s. So I get 4, 10, 13, 21. Divided by 10 is 2.1. All right. That's the old way of doing it. Now here's the new way of doing it. And I know I always get people that are like, what's wrong with that, Jeff? I'll show you in a minute. Right. This is a very small list. I'm going to want this way later when this could be a big-ass list to show you. So here's another way to look at this. Isn't this 4 over 10 times 1 plus 3 over 10 times 2 plus 1 over 10 times 3 plus 2 over 10 times 4? Right? Is that cool? Just breaking them all up. I can do that. That's legal. It better come out and just be the same number or we can throw all this shit away. Forget all about this section. Don't get too excited. And isn't this 0.4 times 1 plus 0.3 times 2 plus 0.1 times 3 plus 0.2 times 4? Isn't that just multiplying all of these? What I just did, isn't it? Okay. And of course, what do we get here if I do this? I get 0.4 plus 0.6 plus 0.3 plus 0.8 is still 1, 1.1, 2.1. Of course it is, because the math doesn't give a shit if I divide first or last. It doesn't care. Is everybody... Sometimes people don't see the... I understand this. You don't see the point of what I'm doing. But the method I'm inventing now better frickin' get the same answer as before, and there should probably be a way of seeing how they relate to each other. So what if I do this instead? If I multiply this column by this column, what am I going to put up here as the name of it? Probably, yeah, XP of X. Am I crazy? Holy shit. So the label tells you what the hell you're doing. So here I get 0.4, 0.6, 0.3, 0.8, which of course adds up to be 2.1. And I know some of you guys are like, fantastic, Jeff. You just got the same stupid answer. We already did it. But what's the new formula now? There's a formula up here. Where did 2.1 come from? How did I get that? By doing what? Adding up what? Adding up, what are these? XP of X. So when I get an XP of X table, how do I get the mean? Add up X times P of X. That's how. Why does that work? Because of that. It's the same shit, just reformulated because there's so many freaking repeats. Why would I write the list down? All right, let's do another one. Let's do one. Let's forget about all this why it works. Let's just attack one with the formula that we made. And also I'll show you why you don't want to do it this other way. Help me out on that one. Let's double check Jeff's math in his head. What should those add up to be, those probabilities? Of course they should add up to be 1. If they don't, either it's because of rounding and it's okay. Like if I get 0.999, are you going to go, that ain't 1, screw you? No, you're going to do the damn thing because 0.999 just means they rounded somewhere, right? Let's see. At least on one level it looks right. 1.01? There's no way. It can't be. Is it? Or you mean like 1.1? 1.01. Damn. All right. How did I do that? You guys should. There's no way. Oh, I see. Okay. All right. So whatever I did, let's make that a 4. Then that'd be 1.00.
right? I appreciate that. I got close. I'm a little surprised. I see 10, 20. Yeah, okay, good. All right. I'm cool with that. So that adds up to be 1.0. Everybody cool with that? You guys change that to 0.04? All right. I got to make one that's valid for it to work correctly. Now, real quick, are you guys cool with the fact that if they gave me this, I could actually just put 1, 1, 1, 1, 2, 2, 3, 4, 4, because that would be representative, and I could do that way. What would I have to do here? I'd have to have 189 4s, 421 5s. Do you want to do that shit? No. So thank God we just spent some time to figure out, is there a quicker way to get the mean if I get the data like this? Yes, because we did what we just did. How do I get the mean? I make an XP of X column. I like it. And I add them all up. I don't know if I want to do this right. 720, 756, is that right? Oh no, don't trust me.
That's right.
Yeah? Neato. Oh shit, I just forgot what that was. Oh, that's going to be half of that, so it'll be 2 points. No.
2.105.
105, okay, I was right. Damn it. So this will be 2.44.
Mm-hmm.
This will be, oh shit, I don't know. I don't want to do this one. Thank you. And that's going to be not too bad.
It's 95.
Point
495.
495? Okay, thank you. That makes sense, Jeff. And then this one's going to be 56, I like it. So if you add those up, if you sum up the p of x's, you will get the mean. That's the formula. That's the first little formula we made for chapter 4. Now, real quick, I always get somebody that adds these up and divides by 5. That does not make any sense. It only makes sense if all of these are equally weighted. But which one is the heaviest, the most important number in here? Which one's the most important data point? The most prevalent one, the one that happens the most? 5. It happens 42% of the time. And 8, it's a close second. So I'll bet you anything, the mean is somewhere in between 5 and 8. These are going to pull it up a little bit. So I don't know. My guess would be 7 point something. I don't know. What do you guys get?
6.356.
All right, I'm cool with that. 6.356. I like it. So the heaviest weighted thing is going to pull the mean towards it. These are here too, so it pulls it up a little bit. The average out to be 6.356. Yes?
So this is different than what we've been doing?
Yes.
Okay.
Now I like that question because not really, but it's just a reformulation of what it's the same thing we've been doing, but there's a bunch of repeats. There's got to be a quicker way to do the math than writing 189 4s and so forth, right?
So you don't divide by 5, why? Because...
All right, I love this. So here's the old formula, right? The old formula is this. Here's the new formula. Why are these the same formula? Because what's on the bottom of a probability? What's on the bottom of a probability? What? Did you say 7? What's on the bottom of a probability? Stop saying that. So if there's 40 people in this room, 40 people in this room, and 3 people are not wearing socks. What percentage are not wearing socks? Why'd you put 40 on the bottom? Because that is the total. So what's always on the bottom of a probability? The total number. These are the same because that has this in it. These are the same stupid formula. That's why I love that question, is because we're not really doing anything new. We're just making it match the way it's given to us. That is the same formula as this. Because P of X has N on the bottom of it. That's beautiful. You don't have to memorize this shit. You just go, it's the same as that. Now, here's the neat thing. Here's kind of a neat little lucky thing. Another word we use for the mean is the expected value. So it's like the best guess. So if you're like, what's guess my salary? Well, you can find the average salary of all community college professors and say, I guess that. That's your best guess. Are you with me? The mean is your best guess. It's called the expected value. And what's the first 3 letters of the formula? EX freaking P. That's some neat shit. So another name for the mean is the expected value, and that's the first freaking 3 kind of letters, to make that look like an E. No? Yes? No? No, Joe. Okay. All right. I always thought that was kind of neat. Now, of course, we still have to talk about how does the standard deviation fit into this, right? And I don't think I'm going to do that to you right now. I am going to give you an early day, since there were no questions. I kind of built in some room for questions, which there wasn't many at all. So maybe next time, come ready. Try out that practice probability worksheet. Do the homework. Come ready with a lot of questions, because I'm going to focus a lot of next time on getting you ready for that quiz.